In Lesson 55, we're going to work on identifying multiples and factors of a given number. And then we're going to draw arrays and area models to represent the factors of a given number. And then we're going to talk about distinguishing between prime numbers and composite numbers. Okay, so first, looking at multiples. What is a multiple? A multiple is a product of a given number and a counting number. So for example, here's the first four multiples of 3. They are 3, 6, 9, and 12. So we're just multiplying the number 3 by a counting number. That number would be 3 times 1, 3 times 2, 3 times 3, 3 times 4. And I have my first four multiples. So let's try by listing the first four multiples of 7. Go ahead and do that now. You should say, I'm taking the number 7, so 7 times 1 is 7. And then you just keep going because we're just going in counting numbers, counting order. 7 times 2, 7 times 3, 7 times 4. It also is like we're adding 7 each time, but you'll see in a moment it helps if you know your multiplication facts. Because what if you wanted to know a specific multiple, like the multiple of 6, we want to know which one is the fourth multiple of 6. So instead of listing all of the numbers out, I can go 6 times 4, which is 24. So try it again. We're going to do what is the third multiple of 8. So you should say, well, third, that's 3, multiplied by 8 equals 24. Now we're going to look at the number 12. Is a multiple of which whole numbers? So that would mean, like, what do we multiply to get 12? Like 1 times 12 equals 12. How about 2? Well, 2 times 6 equals 12. And 3 times 4 equals 12. What about 4? 4 times 3 equals 12. 5, there's no number times 5 that equals 12. 6 times 2 equals 12. 7 times, there's nothing times 7. What about 8? No. 9, 10, 11, and we're back at 12. And 12 times 1 equals 12. So right here, these are all the factors. Remember, we multiplied two numbers. Those are our factors to get a product. So we're just going to list the numbers that we used one time. So these would say are factors of 12. We use the number 1, and then I like to write them order from least to greatest. So I say, okay, we use the number 12, the number 2, and 6, the number 3, and the number 4. Now I can check, I've listed 1, 2, 3, 4, 5, 6 numbers, 1, 2, 3, 4, 5, 6. So I know that I've listed all my factors. I haven't repeated any when I wrote them in order from least to greatest. Well, what if I wanted to find those numbers, the factors of 12, but I want to find it in an array? Well, what's an array? It's kind of like when we find our area using our multiplication table. We find a number, let's say 2. So I go 2 down, and I go how many across to end up with 12? You should say 6. So 2 times 6, like we said earlier, is 12. But just drawing it out like this, that's called an array. So we could do it for another factors of 12. What about 3 and what? Well, that's 3 times 3. That's only 9. So if I had another row here, 3 times 4 is 12. What would my array be if I just had 1 times 12? It would be one row of 12 x's. So that would be 1 times 12. So these are just examples of drawing an array. So now we're going to list the 4 factors of 12, and we're going to look at factors more. Okay, so I have the number 6, so I always start off with 1. That's easy. 1 times 6 is 6. What about 2? Okay, well 2 times 3 is 6. 4, well there's no number 4 times another number to give me 6. Or 5, so then I'm back to 6. 6 times 1, which I've already listed. So these are factors. There's 4 factors for the number 6. Let's try the number 9. 1 times 9 is 9. And 3 times 9, 3 times 3 is 9. So I'm only going to write the number 3 once because it's multiplied by itself, so I don't need to write it again. And there are no other numbers that multiply to get 9. So these are my factors for 9. Go ahead and list the factors for 7. I always said start off with 1 and times the number, so that would be 7. 1 times 7. Are there any other numbers? 2 times something that equals 7, 3 times a number, 4, 5, 6. No, none of those works. We're back to 7. This is a special number here. When its only factors are 1 and itself, we call those prime numbers. So counting numbers that have exactly 2 different factors. So only 2. Exactly 2. Well, what about these numbers that had more than 2? Well, a number with more than 2 factors, that's a composite number. So make sure you know the difference, composite and prime. Prime just has the 2 factors, 1 in itself. Composite has more than 2. So I have a list here. Go ahead and write down, pause the video. Are they prime or are they composite? So there's the word prime. Find that prime number. If you need to, go ahead and list the factors. So like for 8, I would list 1 times 8, 2 times 4. Well, that has more than 2, so that must be composite. Well, 9 we just did before. We said that was 1, 3, and 9. So that number is composite. And 10, you should have listed 1 and 10. 2 times 5 has more than 2, so it's also composite. And finally 11. 1 times 11. No other number, so this number must be our prime number. Do the lesson problems and come get them checked by me.